Okay, I was in the middle of an example again when I ran out of time. We were finding the surface area of this prism, and so far we had done two parts of it. We had done the trapezoid on the top, and just as a recap, there were two of those. Top and bottom are the same, and it was a 2, big base plus little base divided by 2 times height. So 2 times 2 plus 5 for the bases divided by 2 times the height of 3. Then we had said that these two rectangles along the sides were the same. They both have a width of 3.5 and a height of 6. Now we need to add on the other pieces. This rectangle on the back here is unique. It's its own size. It has a width of 5 and a length of 6, just one of those. So 1 5 times 6. And this rectangle on the front right here is also unique. It has a width of 2 and the height of 6. Alright, so those are all of the pieces we need for the surface area right here. So the surface area of this figure is, 2 times 7/2 times 3 plus 2 times 12, that's 6. 6 times 3.5. Okay, plus 5 times 6 is 30, plus 2 times 6 is 12. Let's keep adding right here. I know that 2 times 7/2 is 7, times 3 is 21, and move that over. 12 times 3.5 is, 12 times 3.5 is 42. Plus 30 plus 12. So my final answer here is that my surface area is going to equal 21 plus 42 plus 30 plus 12. 86. There we go, 12. So 86 is the surface area. It's an area measurement, so it's in centimeters squared. Alright, and there we have it. Let's go ahead and look at the next page. The shape right here is a cylinder. And it's technically not a prism, even though it does have many of the same properties, because the ends are not polygons. And even though it's not a prism, we do find the volume in the same way. It has the top and bottom that are the same shape, and we multiply by its height. So we need to know the area of the circle, and then we multiply by the height of this figure. So I do know the area of a circle is pi r squared, then times the height of the cylinder. That'll give me the volume of the cylinder. Okay, for surface area, if I break apart my cylinder, you can imagine that this picture right here is taking a can and taking off the top and the bottom, these two circles, and then cutting it or peeling it open into this large rectangle. So there are going to be two circles, and the area of the circle is pi r squared. That's these parts, top and bottom, the two circles. Then this rectangle has height h, or width h, and then its length is the distance around one of those circles, actually the circumference, 2 pi r. So if I want the area of that rectangle, it's 2 pi r times h. So plus length times width, 2 pi r times h. So that would be the formula for the surface area. And I'm just trying to describe where it comes from, so it makes that formula easier to remember. So the surface area formula is 2 pi r squared plus 2 pi r h. Let's go to the next question. Find the volume and surface area of this cylinder. Volume is pi r squared h. So that's pi times r. Now in this picture, that 4 meters is the diameter, so the radius would be 2. So pi r squared would be pi times 2 squared times h, which is 7. pi r squared h. 2 squared is 4 times 7 is 28. So 28 pi meters cubed would be the exact volume, and the approximate volume would be 28 times pi, or 87.96. meters cubed. Let's find the surface area. The surface area is 2 pi r squared plus 2 pi rh so that's, again, the radius is 2, the height is 7. So I have 2 squared is 4 times 2 is 8. 8 pi plus 2 times 2 is 4 times 7 is 28 pi. 8 plus 28 is 36 pi. This is area, so it would be meters squared, or approximately 36 times pi would be about 113.1, if I round that, square meters. So again, the exact is 36 square meters, and the approximate is 113.1 square meters. Let's look at the next objective. Alright, this is a cone right here, and if you want to view a demonstration on how many times you'd be able to fill a cone up to make a cylinder, you can look at this video right here. There's an underscore right there that you'll need to type in. I need to do a rough demonstration right here. If I imagine this as being a cylinder instead of a cone, there are 1, 2, 3 triangles inside of that cylinder. So if I filled the cone up with water and poured it into the cylinder, how many times would I have to fill it up? It would be 3, which means that the cone is 1/3 of the volume of a cylinder. So it's 1/3 pi r squared h. Remember, pi r squared h was the volume of a cylinder, and a cone is 1/3 as large as a cylinder. Again, if you're interested, that video gives a good demonstration of that property. Right? Now, it's very similar for pyramids. My picture's not going to be as good, but I'll try. You also have the 1, 2, 3 property, and so the volume of a pyramid is 1/3 length, width, height. Length, width, height would be the area of the box. And so 1/3 of that, 1/3 length, width, height, is the area of a pyramid with a rectangular base. Let's find the volume of this pyramid. It's 1/3 the length, width, and height of the base. So 1/3 times 8 times 6 times 5 equals 1/3 times 6 times 5 is 30, and 30 times 8 is 240. If I divide 3 into 240, I will get 80. So 80 centimeters cubed is the volume of this pyramid. Right? And the volume of this cone, volume is 1/3 pi r squared. They told us the radius, it's 4, r squared times h. So I have 1/3 times pi times 16 times 9. 3 goes into 9 3 times. So I'm looking at pi times 16 times 3. 16 times 3 is 48. So 48 pi centimeters cubed is the exact volume, and the approximate volume is 48 times, oops, I didn't mean E. Pi. Hit the wrong key there. So 150.79. So we'll call it 150.8 centimeters cubed. Alright, on the next page you've got some mixed practice, some composite shapes. Don't know what that was. This shape right here is a trapezoid on top of a rectangle. So if I want to find the area of the window, I'm going to add up the area of both of those shapes. So I've got the area of the trapezoid, which is the average of the bases, divided by 2. So add up the bases and divide them by 2. Big base and little base, we've got 5 and 3. So we'll do 3 plus 5 divided by 2 times the height of that trapezoid, which is 2. That's all for the trapezoid. Then plus, for the rectangle, would be length times width, so 7 times 5. So overall, I'll have 3 plus 5 is 8, divided by 2, times 2, plus 35. 2 goes into 2 once, so 8 plus 35 is 43. So I'll have 43 feet. Its area is squared. And the next one, this is a window that has a semicircle on top and a rectangular base. So the area of this window, if we do the rectangle part first, it's 5 times 4. If I look at this circle, if 4 is all the way across the bottom, for the circular part I need the radius, that would be 2. Now I don't have a full circle, I only half of a circle, so I'm going to say 1/2 times pi r squared. Pi r squared would be for a full circle, and this is just a half of a circle. So 5 times 4 is 20, plus 1/2 pi times 4. 2 squared is 4. 2 goes into 4 twice, so that's 20 plus 2 pi. That would be the exact measurement in feet, 20 plus 2 pi, and the approximation would be 20 plus 2 pi, or 26.28. Approximately equal to 26.28 feet squared. I forgot to write the squared right there on those feet. It's area, so it is in square feet.